Welcome to the class, students. Yeah, this year we have very few days are left for mains exam. So these are the predicted topics. These are the most important topics. In the end, one has to revise thoroughly, perfectly, so that he can get better marks in mathematics. And the topics are, I selected 7 topics in first year, like LCD. LCD. This is what limits, continuity, and differentiability. Together, I'm calling LCD, one topic. And the next one is 3D, 3D geometry. That is, and next, third one is vectors. The next one is matrices and determinant. This is also one of the most important. And the straight lines. In coordinate geometry, first year coordinate geometry, straight lines is also one of the most important. And the next one is maxima minima. This is also one of the important topic. And the last one here, functions. So these are the 7 topics of first year. If you are thorough, you need not worry about your mains exam. Okay. In the same way, second year topics. What are the most important topics in second year means? These are the predicted one. Quadratic equations, complex numbers, and binomial theorem, algebra. From algebra, I have taken these 3. And from integral calculus, I suggest you for integration, definite integration, and differential equation. We'll get more number of questions from these 2 topics of calculus. And the next from coordinate geometry, I divided into 2 sections. One is circle, the other one is conics. So circles anyhow. Conics means you know very well. Parabola, ellipse, hyperbola, together we are calling conics. Whoever are perfect in this 15 topic. Individually, if you see that these are 9 and these are 8. Okay. Right. These are 7 are there. These are here. 8 are there topics. So in detail, I wrote clearly what is mean by LCD and what is mean by conics. Altogether, these many topics. If you are concentrate only on these topics, right, that is more than enough for getting better marks in mains. If you have some time is left out for you, then you can go for these 3 topics also. 2 topics of trigonometry I selected: trigonometric equation, inverse trigonometric functions. And the next one is sequence and series. If you go through these all topics, okay, thoroughly, perfectly, guys, I think by the grace of God, you are going to get 99 percentile. Right. Oh, okay. In this session, I would like to discuss topic wise. Right. Every day, I would like to select one topic. Here, all theory points, some 30 questions nearly I'll discuss. And some 2024, 23, 21 till 21. Some other 21 questions I would like to discuss. I would like to give one question paper on it, on each topic. Right? What I'm going to do here, let me tell you, for every topic, see here, for every topic, okay, here I'll explain, right? Okay, first theory, that means all formulas and types of problems I would like to discuss in this. And the next one is some around 20 questions or 30 questions I would like to discuss in that particular topic. And this is the first one. Formulas also you can say that. Right? Formulas are 30, 40 question here, different types. And the third one, what I'm doing, 21, 2021, 2022, 2023, 2024. Especially, I'll focus on this. If time permit, I would like to go up to 2021 also. Okay, some around 20 to 30 questions. I'll select in this, I'll discuss. One paper, one question paper. Question paper. One question paper on this, on every top, on this top. If whatever it may be, individually, if I take limits, yes, on limits also I would like to discuss like this. Those whoever or follows this strictly, doing every day one question paper and doing the, listening this theory and doing one assignment and observe carefully these all problems, how I'm solving all those things, so that you will get perfection in it now. There is no doubt about it. Okay. Well, let us start the topic, guys. Okay. I'll start with limits topic. In this limit topics, you see this Nana. Standard limits. We have standard limits. This is the first one. Limit extends to a x to the power of n minus a to the power of n divided by x minus a. N into x to the power n into a to the power of n minus 1 you will get. This is the second one. This is third one. Okay. E to the power of limit extends to 0 a to the power of x minus 1 by x is 1. Limit extends to 0 a to the power of x minus 1 by x is what? Log a. And the fourth one is limit extends to 0, 1 plus x whole to the power of 1 by x is e. And the fifth one is limit extends to infinity, 1 plus 1 by x to the power of x is e. And the sixth one, limit extends to 0, sin x by x is equal to 1. And limit extends to 0, tan x by x is also what? 1. How many standard limits are there? Means 7 standard limits. Why we are using limits? Limits are used in solving the problems to evaluate indeterminate forms. Undefineds are different, indeterminate forms are different. How many indeterminate forms are there means you can tell this now. Okay, here I'm highlighting 5, but actually it is 7. See this? Here, 0 by 0, one of the indeterminate form. Why we are saying indeterminate? Because the answer is here, we cannot predict whether it is maybe 0 or it may be infinity. In the same way, infinity by infinity is also what the same. Infinity or it may be 0. That's why we cannot say that it is determinate. Indeterminate we are saying. That's why. Infinity minus infinity is also what? One of the indeterminate. Because we are getting two answers. One is infinity, the other one is minus infinity. Like that, 0 into infinity is also one of the another indeterminate forms. Another one is what? 0 to the power of 0, 1 to the power of infinity, infinity to the power of... These all are what? Exponential form. I would like to explain one of this. 0 to the power of anything is what? On a 0. But something to the power of 0 is 1. 0 or 1. Which one is correct? We can't say. That's why this is also indeterminate. Now, undefineds are different. Undefineds are also, if you go through this, clarity point of view, I'm giving you. Okay, 7. This is, if you define a like this, any real number, not 0, then a plus infinity is like this. Infinity, infinity minus a is infinity. A minus infinity is minus infinity. A into infinity is infinity. Infinity by a is what? Something, whatever it may be the number, infinity you are getting. A by infinity is 0. फिर डरने की कोई बात नहीं यार, ये 3 एरियाज आपको आना चाहिए. बेसिक, स्टैंडर्ड लिमिट्स, इंडिटरमिनेट फॉर्म, अनडिफाइंड. रूट इंफिनिटी को इंफिनिटी ले सकते हो यार, ऐसा. ओके, हियर अभी अपन सब्जेक्ट में चले. Okay, let us move on to this topic. In limits, we have around 10 to 12 types are there, Nana. So the type 1, I would like to discuss for each type 1 or 2 problems, more or less. Right. See this, the type 1. What is the type 1? After knowing this all, okay, this all formulae, now we'll move on to the type 1. Type 1 is very simple. Just you substitute the limit value here, 0, 0, so 2, you are getting 0, 0, 0, 5. Straight away, we are getting the answer. This is one of the easiest one. Leave it. Now, when you are substituting here, 1, you are getting what? 0 by 0 form. Then what you have to do, one of the way of evaluating this limit is factorizing. क्या करना है यार? Factorize करना. कैसा? देखो यार, इसको मैं factorize बना रहा हूँ. 2x minus x plus 2 divided by x minus 1. Limit x tends to 1. x अगर से कॉमन निकाल दिया, x minus 2, 1 यहाँ से, x minus 2 by x minus 1. That means finally we will get here x minus 1 is a one of the factor in the numerator as well as in the denominator. So the common one you cut it out. After cancelling this, what is the left out? Whatever it may be, the left out one is there you substitute the limits. You will get what? Minus 1. In this way, we are evaluating second one. And come to the third type. What is that third type? Whether it is in here, wherever you find root like this. Here I have taken one example where root is present in both. Right. How I am evaluating this? Sometime what happened, it may be only in the numerator. Sometime it may be in the denominator. It may be you will find. So if you find like this, go for here also we are getting 0 by 0, no doubt. If you substitute x tends to a value, x in the place of x a, if you substitute, you will get what? 0 by 0. So better go for rationalization. If you rationalize the numerator and denominator separately here, what is that? Rationalizing. Rationalizing numerator, denominator. Both I am doing it. How? See this? A plus 2x root 3x. The question whatever he has given here, I have taken. देखो यार, ने जो दिया क्वेश्चन में ले लिया. देखो भाई, यहाँ पे it is a, sorry, 2 root x. If it is here, go for the rationalization. 2x plus root 3x. I am rationalizing the numerator. A plus 2x plus root 3x. Yeah, fine. Okay. यहाँ पे देख ले भाई, डिनोमिनेटर का रेशनलाइज कर रहा हूँ. 3x plus a plus 2 root x. Here, the root of 3a plus a, 3a plus 3x. 3x plus a plus 2 root x. ऐसा करा. यार ये दोनों को ले ले, यहाँ पे ये दोनों को ले यार, बन जाएगा क्या? Limit extends to a. You better take down this too. You will get here a plus 2x minus 3x. Right? In the denominator, you will, if you take these two, यार यहाँ तो बन रहा ऐसा 4x. You'll get like this. Whatever the left out one is there, you better take here. What is the left out here? 3x plus a plus 2 root x divided by root over a plus 2x plus root 3x. This is the left out one. If you simplify now, here, what you are getting here? A minus x. Whereas here, you see this a minus x you are getting. Right? You are getting here also a minus x you are getting. So a minus x, if we, after cancelling this, the left out one is this one only. 3x plus a plus 2 root x. And here a plus 2x plus root 3x. Here you substitute there. If you substitute the limit value, substitute kar de bhai, limit value. You'll get 3a plus a, 2 root a. In the denominator, a plus 2a plus root 3a. Finally, what you are getting here? This is, see this now? You are getting 4 root a. Here, how much? 2 root 3 root a you are getting. This is gone. So your answer is 2 by root 3 is your answer. You got it like this. Okay. I'll move on to the next page. Yeah. This is okay. We'll go on to the next. Type 4 is L'Hopital rule. While writing here L'Hospital, we have to write L'Hospital rule. Well, we have to read here L'Hopital rule. In this L'Hopital rule, we are going to discuss about 4 cases now. How many? 4 cases. What are those? What are the 4 cases? The 4 cases are like this. If you find after substituting the limit value, if you got 0 by 0, one of the indeterminate form, then he says that if the given limit is in the form x, limit extends to f of x by g of x, after substituting limit value, assume that you got it 0 by 0. Then he'll say differentiate numerator and denominator separately. They'll say like this. Differentiate numerator and denominator separately and substitute the limit value. If you got finite, the process end. If not, continue the process till to get a determinate number. Here are the 2 examples I've taken here. It can be written as limit extends to 1. You see this now. X if you substitute here, 1, 2, 3 up to n, I can write. Yeah, you see the first example. I have taken here this example. The moment you are expanding this, it is in the form of what? 0 by 0. Why I'm saying 0 by 0? Because if you write here like this, x square, okay, x cube, so on, it will go up to x to the power of n. N is also there, and x minus 1. Clearly, if you substitute the limit value here, definitely you'll get 0 by 0. So the moment you're getting 0 by 0, you differentiate numerator. 1, 2x, and this is 3x square, so on, n x to the power of n minus 1, and this is 0. And whereas in the denominator, 1 minus 0 ho jayega bhai. So the moment you are substituting limit value, you are getting what like this? It's a finite one. So that answer is n into n plus 1 by 2. Right, one time we differentiated. Whereas here, it is also 0 by 0 form. Let us see, I'm differentiating this one. The moment if I differentiate this, I would like to get 1 plus x, 1 by 1 plus x. Here not 1, it is x nano. If you differentiate, 1 you are getting. This is what 2x. Once you see this, once we differentiate it, and when we substituted the value, we are getting 0 by 0 form. It is 0 nano, sorry. It is 0. Limit x tends to 0, log 1 plus x minus x by x square. Actually, problem is this. The moment you are differentiating, you are getting what? Like this. 0 by 0, once again you are getting. I said it to you the same thing here. Whenever you will get 0 by 0, go for the next step. Right, go for the next one. Then when once again you differentiate here. If you differentiate here, you are going to get minus 1 by 1 plus x whole square. This become what? 0 and 2 you are getting. Substitute the limit value here. You will get minus 1 by 2. Like this. Till to get a determinant number, we have to differentiate. This is case 1 I discussed. Now case 2 is what? If you substitute the limit value, you are getting infinity minus infinity. Whenever you will get infinity minus infinity, you remember LCM you have to take. What is that? LCM. How? You see this one, I'm dealing this question. You will get here sine h square x minus sine square x after okay taking LCM. LCM लेने के बाद ऐसा आएगा ना भाई. चलो तो देखो यार यहाँ पे साइन स्क्वायर एक्स और यहाँ साइन एच स्क्वायर एक्स ऐसे दो आ रहा. इसको डिफरेंशिएट मत करो भाई. You need not differentiate now. Be careful. You have to write here sin h square x, sin square x, and replace these two by x square. And this one is also what? By x square. Overall, what you'll get? X to the power of 4. Now, it is in a perfect form. These type of simple changes you have to do now. So here, what happened here now? You see 0 by 0 is there. Once again, I would like to differentiate. I converted by taking LCM here, infinity form, infinity minus infinity form into 0 by 0 form. Now I would like to differentiate numerator and denominator separately. What I'll get here? 2 sin hx, and sin hx derivative is cos hx. This is 2 sin x cos x divided by 4x cube we will get once we differentiate it. Yeah, you can write like this, Nana. Sin h2x. This is what? Sin 2x divided by 4x cube. Again, it is in the form of 0 by 0. So what I said, till to get a determinant number, you have to continue this process. Now you differentiate here. 2 cos h2x, 2 cos 2x here, and this is 12x square. Still it is 0 by 0 form is there. Okay. So now limit x tends to 0. Once again, if you differentiate here, 4 sine h2x, okay, plus 4 sine 2x divided by, this is 24x. Once again, it is in the form of 0 by 0. So better differentiate once again. How much? 8 cos h2x, and here also 8 cos 2x divided by 24. The moment you are substituting limit value, you are not getting 0 by 0. It will be like this. How much, Nana? 16 by 24, you got it. So 2 cases we discuss. Another 2 are there. I'll go for the next page. Okay. Third case of L'Hospital rule is 0 into infinity. whenever you will find 0 into infinity, you remember replace 0 as 1 by infinity form or infinity as 1 by 0 form. We are not changing anything now. Yeah, 1 by infinity can be written on nothing but what 0. And here 1 by 0 is nothing but infinity. The other form of these two we are writing here. So you see this example, you'll understood. मैं इसको देखो, ए एग्जाम्पल को देखो, बहुत अच्छी तरह समझ में आ जाएगा यार. यहाँ 1 सब्स्टिट्यूट करो यार, ये 0 हो जाएगा. यहाँ 1 सब्स्टिट्यूट करो, infinity होगा. So this means what? 0 into infinity form is there. What to do here? I said it to you that whether you can use this or this one. I feel that this one is easy for me. Now what? 1 minus x I'll keep as it is. This tan I can write as cot, 1 by cot pi by 2x. Because 1 by cot is nothing but tan x. That's why I'm writing here. So like this, that means it is in the form of what 0 by 0. Now you can apply the rule. If you differentiate 0 minus 1 minus cosecant square pi by 2x and internal derivative pi by 2x derivative is what? Pi by 2. Substitute the limit value minus 1 here, minus 1 and pi by 2. So your answer is what? 2 by pi. You got it? 2 by pi. So whenever you will find 0 into infinity form, like this you have to solve. And now the next one is 0 to the power of 0, 1 to the power of infinity, infinity to the power of 0. I have taken one example here to do this one. If it is 0 by 0 form or out of this all, any one of the three exponential form, you better take first logarithm, apply logarithm on both sides. What do you have to do? You have to applying logarithm on both sides. How? Like this will get log L. And you can write here limit x tends to 0. See this now. Tan x log of sin x. What you got here? 0 into infinity form once again. Right, 0 into infinity form. That means we converted this form to, after applying logarithm, 0 into infinity form. 0 infinity means you know very well case 3. By using case 3 you can solve. How? See this one. I don't want to change this, but here tan x can be written as 1 by cot x. Now it is in the form of what? Infinity by infinity form is there. Now differentiate. Once you got it in the indeterminate form, differentiate. 1 by sin x you are getting log sin x derivative. Sin x derivative is cos x here. Cot x means minus cosecant square x we are getting. So limit x tends to 0 minus. It will be like this finally. Finally, it will be in this form. Nana. Once you got it like this, just substitute the constant value. We are getting what? 0. What is that? Log L is 0. But actually we want L, e to the power of 0. L is equal to how much? 1. We are getting here. So with this case 4, okay, case 4 of log L'Hospital rule is completed. Now we'll move on to the next. ओके सो टाइप 4 खत्म हो गया यार. टाइप 4 में L'Hospital रूल डिस्कस करे थे, उसमें 4 केसेस डिस्कस करे, कैसा करना क्या करना सभी. अभी टाइप 5 पे जाएंगे. टाइप 5 में क्या है यार? टाइप 5 में देखो भाई, एक कॉचीज फार्मूला है. लिमिट एक्सटेंड्स टू ए एफ ऑफ एक्स टू द पावर ऑफ जी ऑफ एक्स. जहाँ कहीं पे भी आपको दिखेगा 1 टू द पावर ऑफ इन्फिनिटी फॉर्म, इस तरह से यार आप ना ए फार्मूला यूज करना होगा. व्हाट इज दैट? व्हाट इज सेड हियर? e to the power of limit x tends to a f of x minus 1 into g of x. You are supposed to use this formula. ये फार्मूला आपको इस्तेमाल करना है. कैसा यार? एक एग्जांपल ले रहा हूँ. देखो यार, यहाँ पे एग्जांपल बहुत सारे मिल जाएंगे आपको. देखो एग्जांपल ले रहा हूँ. लिमिट x tends to 1. देखिए भाई, लिमिट x tends to 1. देखो यार, लॉगरिथम ऑफ 3x base 3 whole to the power of, I would like to take here log 3 base x. कोई घबराने की बात नहीं यार. 1 सब्स्टिट्यूट करोगे 1 टू द पावर ऑफ इन्फिनिटी आएगा. ये बेस एक्स है, log 3 बेस एक्स है. ठीक है भाई. हाँ चलिए अभी देखो यार क्या होगा. दिस कैन बी रिटन एज लिमिट एक्स टेंड्स टू 1 log 3 बेस 3 प्लस log x बेस 3, ऐसा लिख सकते भाई. एंड दिस इज ऑल्सो व्हाट? log 3 बेस एक्स इज है. यू नीड नॉट वरी. अब ये क्या होगा देखो यार, 1. जब 1 सब्स्टिट्यूट करोगे तो ये 0 होगा. 1 टू द पावर ऑफ इन्फिनिटी फॉर्म में आ गया. 1 टू द पावर ऑफ इन्फिनिटी. तो मैं यहाँ पे कॉचेस फॉर्मूला यूज कर ले रहा हूँ. ऐसा यार, लिमिट एक्सटेंड्स टू 1. दिस इज 1 प्लस लॉग x बेस 3 minus 1 into here what I have log 3 base x. देख भाई क्या हो रहा है यहाँ पे, लिमिट x टेंस टू 1. यार देख log x बेस 3 ये कैसा लिख सकते हैं यार, इसको ऐसा लिख सकते, तो डिफरेंशिएट भी करने की जरूरत नहीं है. देख भाई दो सेम है, कट जाएगा, बचा क्या यार, लॉग ई रहा तो वो सब्स्टिट्यूट करेगा, नहीं तो नहीं, तो ई आंसर बच गया. लाइक दिस वी आर इवेलुएटिंग टाइप 5. Okay. I would like to do one more problem on this one in type 5. Yeah, this is the one of the problem I've selected here. It is also the moment you are substituting limit value, this is 0, this is also 0. So that 1 to the power of infinity we are getting. So what I said, whenever you are getting like this, Nana, you can write e to the power of limit x tends to 0, 1 plus lambda by x plus mu by x square minus 1 into 2x. I am applying that formula. Whatever Cauchy's formula I have given, that I have applied here, e to the power of 4. This is limit wise. So you see this, finally what we have, lambda by x, mu by x square we have, okay, into 2x is there. Not to forget about this, e to the power of 4. All right. The moment you are writing here, limit x tends to infinity, you take this side inside, 2 lambda you are getting. Here how much you are getting? Mu, 2 mu by x you are getting here, e to the power of 4. You see this now, x tends to infinity means this become what? 0. Something by 0 is nothing but, yeah, something by infinity is nothing but 0. What is the left out one? 2 lambda is equal to 4. So lambda is equal to how much? 2. That means here mu can be any real number. Okay, mu can be any real number. So here in type 5, I introduce one. Okay. Now in type 6, I would like to introduce one more formula. That formula is would extends to 0, 1 minus cos to the power of n ax by x square is equal to what, Nana? Na square by 2. In the place of x, you may have here sin x, or it may be sin inverse x, or it may be sin hx, or it may be sin h inverse x. In the same way, it may be tan x, tan inverse x, right? And tan hx, tan h inverse x. Anything is there, you can apply this formula. How? You see this now. Here I've taken here. That means you can replace these two by this one by 2x, this one by x. How? See this now, like this. 1 minus cos cube x. I would like to replace this one by 2x and this is x. Finally, what I got? 1 by 2 outside. It extends to 0. 1 minus cos cube x by x square. Now it is in the form of given perfect formula. Right? 1 by 2 as usual already is there. And if you apply the rule, 3 into 1 square divided by 2, finally your answer is what? 3 by 4. Now, one more question is there here. You see this. It is also one of the good question. Limit x tends to alpha. It is not infinity, alpha. Yeah, you can write this as, because alpha, beta are the roots of this equation, mean you have a choice to write like this. X minus alpha, x minus beta. You can write a into. And here we have x minus alpha whole square only. So you multiply by, ये multiply कर लो यार, x minus beta दोनों तरफ multiply करो, ऊपर और नीचे यहाँ पे. So now it is in the perfect form. I'll turn the page. You see here, once again I would like to write here x minus alpha. I'm multiplying x minus beta both the side. So what I have here, 1 minus cos a into x minus alpha, x minus beta divided by, it can be written as x minus alpha, x minus beta whole square. I modified the limit here, tends to 0 हो जाएगा. यहाँ पे x tends to alpha ही रहेगा भाई. X minus beta whole square I multiply, divide with this. Now it is in the form of formula. So a square by 2 I can write. Whereas here alpha minus beta whole square I can write in this way. So with this type is completed. Now we'll move on to the next. Okay, limit tending to infinity. In tending to infinity, these are the basic rule is there. One of the basic rule. If the numerator degree and denominator degree is same, guys, just you can write limit extends to infinity. What you have to write is clearly highest degree term you select in the numerator and the coefficient is what? 3. You select that. And here highest degree term x square here, select 2. When you have to write like this, if the degree of the numerator and degree of the denominator is same, then you have to select highest degree term in the numerator, coefficient, and highest degree term coefficient in the denominator like this. How? Just you take x square common. What is that? I'll show you. If it extends to infinity, how we got means x square you take common, 3 by x, 1 by x, you will get here 11 by x square. Here you see this 11 by x plus 4 plus 100 by x square you are getting. You see this, Nana? X square gone. The moment x tends to infinity, 1 by x tends to what? 0. So you will get what? 3 plus 0 plus 0. And here 0 plus 4 plus 0. Finally, 3 by 4. You got it here like this. So in this way, we are evaluating here. Better directly you can write here. Okay. Now the question is here. If the numerator degree is more, the answer is infinity. If the denominator degree is more compared to the numerator, the answer is what? 0. These are basic questions. That is, you leave with these questions. Now some good questions are also there tending to infinity. Some limit extends to infinity. You see here, I would like to select some. Yeah. You see this one example. Here I have selected another example. What is that example here? You see this now. I want to tell you this. As n tends to infinity, a to the power of n tends to what? 0 whenever a lies between 0 and 1. Or n tends to what? Infinity if a is greater than 1. This one I want to use over here. So limit extends to infinity is there. Something to the power of, this is all infinity. This sine infinity. Remember, sine infinity is something k, nana, that k belongs to minus 1 to 1. It's a finite value, not infinite value. Right. So what exactly happened over here? Let me write sine a by 5 to the power of x. Can I write here like this? 5 to the power of x. I want to multiply a divided with a. As n tends to infinity, just now I said it to you that a to the power of n tends to infinity here. But if I write here 1 by 5 to the power of x tends to 0, is absolutely right. Sine a by 5 to the power of x by a by 5 to the power of x. This is what perfect formula here. So answer is A, nana. We are getting answer is 1. Now here some series problems are also there. Let me go for the series problem. Let me turn the page, guys. You see, one of the example I've selected like this. In this question, n tends to infinity is there, but it is in the form of what series he has given. Yeah, you need not worry. You take this one, I would like to apply sigma. That is k. I've selected k to n here. 5 to the power of k plus 3 to the power of k divided by 10 to the power of k you can write. Or else you can write limit n tends to infinity sigma k is equal to 1 to n. This is 5 by 10 means 1 by 2 sir, to the power of k, and 3 by 10 whole to the power of k you can write. What happened here? N tends to infinity. If I expand here, 1 by 2, 1 by 2 square, so on, 1 by 2 to the power of n, one series. Another one is, this is, okay, this is 1 minute. Let me check the problem. Okay, here 2 to the power of n, not 3 to the power of n, so that we can write like this. And sigma k is equal to 1 to n. See now, 5 by 2 means 1 by 2, 5 by 10 means 1 by 2 I wrote, 2 by 10 means 1 by 5 I'm supposed to write here. So this, it become what? 1 by 5 plus 1 by 5 square plus so on plus 1 by 5 to the power of n. Both are what? GP series. Right, GP series are there. Yeah, I'm using that formula. 1 by 2 to the power of n divided by 1 minus 1 by 2 to 2. Okay, and for this, 1 minus 1 by 5 to the power of n divided by 1 minus 1 by 5. Of course, 1 is there. I use this formula. What is that formula, Nana? Here, this is the formula a plus ar plus so on plus ar to the power of n minus 1. A 1 minus r to the power of n by 1 minus r. R is less than 1. You know very well. This is GP formula used here, and I got it. As you know very well, as n tends to infinity, 1 by 2 to the power of n tends to 0, as well as 1 by 5 to the power of n is also what? Tending to 0. This is the fun. So now, the moment you are substituting here corresponding values, what happened? 1 minus 0 by 1 by 2 here, 1 minus 0 by, here it is 4 by 5. Finally, 2 plus 5 by 4, here 8, 13 by 4 you are getting. Okay, shall we move on to the next, Nana? Okay, type 8 you see, Nana, some expansion. Here I have given some expansion. Sin x expansion is like this. This is 3 factorial. X minus x cubed by 3 factorial. X to the power of 5 by 5 factorial minus so on infinity. Cos is what like this. X, these are what odd numbers. These are even number. Alternately, minus and plus is there. Whereas here it is replica of this one. It looks like that, but it is little bit different. X cube, x to the power of 5 like this, but the coefficients are going to be changed. Yeah, tan x is different. Okay, if you learn, it's good. If you learn sin inverse x is like this, then tan inverse x is in this way. Cos inverse means you know very well, pi by 2 minus sin inverse x. By using that, we can. If you learn some series like this 6 at least, it is useful for you. For example, you see this problem. What? Limit x tends to 0. What I'm writing here, directly if you know the formula, you can write like this. Right? You have an advantage. Okay, of course, you can solve this one by using the Taylor-Hospital rule also. But if you use this series, it's very good. It shows that you are perfectly okay while solving the problems. You see this, Nana? These two are gone. And left out one is this. So limit x tends to 0. Okay, x to the power of 5 we take common. 1 by 5 factorial minus x square by 7 factorial. It will be like this. And here x to the power of 5 is there. Cut it off. And if you substitute the limit, everything become what 0. Only 1 by 5 factorial is left out. If you differentiate this one 5 times also, you will get the same answer. 1 by 120 you will get. Let me take one more example here. Limit x tends to 0. Okay, limit x tends to 0. I'm taking right now here. Limit x tends to 0. I'm taking here. And let me select the problem here. Nothing else. Yeah, one more example I've selected in this series problems. Yeah, just I would like to substitute the sin inverse x series. X plus 1 by 2 x cubed by 3 plus 1 3 2 4 x to the power of 5 by 5 so on. All are what pluses is there. And whereas sin x series here, just now I wrote here x minus x cubed by 3 factorial, x to the power of 5 by 5 factorial, so on. Minus. Okay, whereas here x cube is there now. Right, minus x plus x get cancelled. Here you see this, Nana. If you take x cube also common here, what happened here? Limit x tends to 0. If you take x cube common, this is the left out one in the first one, 2 into 3, and 1, 3, 2, 4, 5, x square, so on in the first. In the second one, 1 is left out and 1 by 3 factorial. Here x square by not 1, already x be cancelled, 1 by 3 factorial minus, okay, here minus of minus it become what plus, and this is minus 5 factorial plus 1. Okay, so 1 is left like this, divided by x cube. Cancel this, Nana. If you substitute the limit value, what is the left out one? Here 1 by 2, whereas here 1 by 3 factorial is left out. So 1 by 2 plus 1 by 6. So it becomes 6 if you take here, 4, 2 by 3 you are getting. So series problems we can solve in this way. Right, we'll move on to the next one, Nana. I'll go for the next type and next page. Yeah, you see this, Nana, finding constant, or you can call it as application of L'Hospital rule also. What happened here, you see, you have to be careful while doing this one. This type, b sin x divided by x cube here is equal to 1. See, substituting the limit value 0 by 0 we are getting. So directly straight away you differentiate here 1. Okay, UV formula I'm applying here like this. X 0 minus a sin x I'm getting here. And here b cos x I'm getting. And in the denominator 3x square it become. Right. Now if you substitute limit, numerator is not 0 but denominator is 0. Something by 0 is infinity, but actually that fellow has given infinity 1. So that means limit x tends to 1, numerator must be 0. So here if you substitute 0, A, this is what 0, minus B equal to 0. That means A minus B is equal to 1, equation 1 we got it. That why we wrote like this? Because numerator is not 0 but denominator is 0. Something by 0 is infinity, but actually here given 1. Means numerator must be 0, then only it is flexible for the further step. So that's why we have taken like that. Once you consider numerator is 0, differentiate once again. So what happened here? Minus A sin x. Okay, here UV formula. A sin x plus x minus A x cos x plus B sin x. Okay, divided by here 6x equal to 1. Again 0 by 0 is there. Once again you differentiate Nana. Okay, what happened here? Limit x tends to 1 minus A cos x minus A cos x, UV formula minus A cos x and minus x plus it become sin x, and whereas here B cos x divided by 6 you are getting is 1. Substitute here minus A minus A minus A plus 0 plus B is equal to 6 you are getting. Minus 3A plus B is equal to 6. Right? Well, see, for every type I would like to select 1 or 2 problem. I can go for more than one. 2 equations we got it. One equation is this, another one is this one. So when you solve these 2 equations, you will come to know the values of these 2. What is that? 5. A is equal to minus 5 by 2. And what about B means A plus 1 is there, minus 5 by 2 plus 1. So B is minus 3 by 2. Like this we are using finding constant. Here sometime what happened, we can use that series also. Okay, you can use series also. Let us go for the next type, Nana. Okay, see the 10th type. What is that? Sandwich rule. Sandwich rule says what? If 3 functions are like this, f of x, g of x, h of x is like this, and the limit at x is equal to a limit, limit x tends to a f of x is equal to limit x tends to h of x is L, then definitely that means the middle one must be equal to 1, L. If it is L, definitely the middle one is also what? L. How best we are using this? See, well, you can understood in a better way by using this. Okay, by taking this example, I would like to explain to see this Nana. Step X that you can write as X here X minus 1. Here 2x minus 1 less than step 2x less than equal to 2x. It will go up to n Nana. Nx minus 1 less than step nx. Okay, here nx you are getting. It will so on it is. The moment you are adding, what happened here? X plus 2x plus so on plus nx minus n less than, this is step x plus step 2x so on plus step nx, step this, right, nx, and whereas here x plus 2x plus so on plus nx we are getting. Now you see here, the moment you are taking x common, you will get 1 plus 2 plus so on plus n minus n less than equal to, this is step x is there. I want to write the last one here, nx, and here it will be like this, x if you take common, 1 plus 2 plus so on plus n it is. Now if you apply the limit as well as simplification, n tends to infinity, x here, n into n plus 1 divided by 2 minus n, and I am dividing here with n square Nana. So limit also I am applying, and at the same time I am dividing. So whatever the given problem is there, we got it like this. Just check it out. See this banana? Like this we got it. X here, limit n tends to infinity, not x tends to it is. N into n plus 1 divided by 2 n square. I divided with n square. So if you take n square, take common and cut it off, what is the left out one means? Here x, of course, 1 plus 1 by n divided by 2, and when you write here and dividing with n square, it will be n like this. And here, if you say this question is totally e Nana, you can write e over here, right? X as it is, limit n tends to infinity, 1 plus 1 by n divided by n square get cancelled, guys. and the left out one is 2. You substitute the limit value here. What happened here now? You see this? This become what? 0. X by 2 you are getting minus 0 less than equal to, this is E less than, okay, this is less than only, sorry, less than, and this is less than equal to, what happened here? X by 2. Both the side X by 2. So that means E is also same. Limit n tends to infinity, step x. So 1 plus step nx divided by n square become what, Nana? X by 2 we are getting. Okay, I'll turn the page here. We'll go on to the next problem, guys. Yeah, I selected one problem here. Limit r tends to r be a positive increasing function, he said. If it is a positive increasing function, you better take like this, Nana. Diagrammatically, I would like to explain here. I've selected the values like this, x, 2x, and 3x are what? Increasing. So it may be like this. This is what f of x. And it will more than f of x here, 2x, because it is increasing. Right, here f of 3x it will be like this. Because increasing it will be increasing like this it is going. So clearly I can write here f of x less than equal to f of 2x less than equal to f of 3x. Right, it will be like this. Now I want to divide this one by x, Nana. What happened? Limit f of 2x divided by f of x, and here f of 3x divided by f of x. Now you apply the limit x tends to infinity. Okay, like this, x tends to infinity, f of 2x by f of x, and here limit x tends to infinity, right, right, f of 3x by, okay, f of x. Now you see, guys, what he has given here, it is 1. Okay, in the middle what we have, x tends to infinity, f of 2x by f of x we have less than equal to, what is the value of this one? Already that value has given is 1. When you got like this, what is sandwich rule says? The middle one compulsory should be equal to what? The one which we got it over either side. This is also 1. This is the most important one, right? So here we discussed 11, and now we'll move on to the next one, Nana, type 11. In type 11, we'll discuss here existence of limit. Okay, here existence of limit. What is that existence of limit means? See this, Nana. In neighborhood, we are discussing a minus if you take, if this exists, we'll say that LHL, left hand limit. Limit x tends to a plus if you take f of x, right? If it exists, then you can say that this is the right hand limit. If it exists, both are exist and equal, right? Limit x tends to a minus f of x is equal to limit x tends to a plus f of x. Both are finite and equal, then only we can say that limit is exist. Limit is exist, we can say. There are so many cases are there. Simple case I'll take here. Limit x tends to 2. Suppose if I take step x, is it exist means? Yeah, usually we have to go for LHL and RHL when if mod x is there, step x is there, right, e to the power of x is there, or 1 by x is there. In this, wherever you find like this, our fractional part function is there. Okay, in these 5 cases, usually, in generally, we'll go for it. Some more cases are also there, but usually we'll go for like this. Limit x tends to 2 minus step x, Nana. This is step x means GIF, greatest integer function. If it is 2 minus means less than 2. Less than 2 means nearby, neighborhood of 2. Neighborhood of 2 is what? 1.999 something. 1.99 value is how much, Nana? Step value is 1. And whereas here limit x tends to 2 plus, if I said step x value is how much? 2 here. You see this limit does not exist. It doesn't mean that always limit does not exist if it is nicer. As an avatar. Limit x tends to 1. If I take here 1 minus x. Okay, here x minus 1. See one example I'm taking here. Let me. Okay, you see this now. Here I'm taking LHL. What is that LHL? Limit extends to 1 minus x. Second example I have taken here. This is step function is there. JF, please remember JF it is. Right, and here 1 minus x is there. Yeah, you can take here x is 1 minus h now. As x tends to 1, h tends to 0 now. Limit h tends to 0. What happened here? Wherever x is there, I am substituting 1 minus h. In the box also, 1 minus h minus 1. Here, 1 minus 1 plus h will get. See, I am not applying the limit here. After evaluating step function, if anything is left over in terms of h, then only I'll apply. Here minus h, here h we are getting. See, I'm not applying. So here h is there as usual. This value is what? Minus 1. Whereas here 0. No, there is no step function. Now you can, if h is left over, then apply the rule. If you apply the rule, what happened here? 0. If you apply the limit in the sense, minus 1 you are getting. So LHL, what you got? Minus 1. Let me move on to the next one, Anna. I mean, not next one, next field, RHL. What is the question here? Limit extends to 1 plus 1 minus x plus step x minus 1 plus 1 minus x step. Yeah, x is equal to 1 plus h if you take limit, right, as x tends to, you know very well here. Okay, here x tends to 1 and h tends to become what? 0. So limit h tends to 0, 1 minus h here, the moment you are substituting the value of that, 1 plus h minus 1, here 1 minus h you are getting. So finally, limit h tends to 0, minus h, here h, whereas here minus h is left out. Of course, here h tends to 0, minus h is there. This become what? 0. This become what? Minus 1. 0, minus 1, minus 1. So LHL is equal to RHL. We can say limit exists. Limit exists, you can say. Okay. How many types? 11 types are there. Yeah. Type 12 also you can say some miscellaneous examples are there. Series problems you can take. Right, some series problems are there, some formulas are there. Formulas means, yeah, I would like to give this formula, Nana. Please remember, x plus a divided by x plus b whole to the power of x plus c. You can write e to the power of x plus c here, e to the power of a minus b. One of the best formula. You can remember this. Okay. What is that? You see this example I have taken x minus 2 by x plus 3 here. So here x, only x is also there. Minus 2 minus 3 is the answer. Limit extends to infinity. Here x plus 2 by x minus 3 is there. Of course, x minus 7, whatever you want, you can write here. 2 minus of minus 3, it become what? E to the power of 5. This is one example. Another formula is that limit extends to 0, a to the power of x plus to the power of x by 2 whole to the power of 1 by x is equal to root ab. X nana, all are x. X tends to infinity. This is another formula. Right? I'll turn the page here. What is that now? Limit x tends to 0. See here, 1 to the power of x, 2 to the power of x, so 1 plus n to the power of x divided by n whole to the power of 1 by x is there. Yeah, you can write nth root of 1, 2, 3, so on, n. Nth root of factorial n you can write. That is also one of the formula. Another formula I would like to give, limit n tends to infinity, sigma n to the power of k by n to the power of k plus 1 if it is. So your answer is k plus 1. Please remember this formula also. What is that? Most of the series problems we can handle in this way. You see this one, Anna? Sigma n square by n to the power of 3 is there. So your answer is what? 1 by 3 you can write. Suppose here if I write here like this, guys. Okay, see this one. N square plus n divided by, okay, here n cube is there. What happened here? Limit n tends to infinity, sigma n square by n cube. Of course, this is good. Sigma n by n cube is there. If the difference is this 1, then answer is 1 by 3. If difference is more than this, that means denominator power is more than the numerator. Okay, not 1, more than 1. So answer is become what? 1 by infinity is 0 you are getting. So 1 by 3. Numerator power is more. The answer is what? Infinity you are getting here. So we discuss all types of, right, all types of types, all types in the case of limits, Nana. Now, okay, I'll discuss, I think I discuss all the methods, all the types I discussed, 12 types, right? 12 types I discuss here. Now I would like to give one exam, one beautiful assignment, Nana. You can say that final preparation, okay, of limits, right? Final preparation of limits. I selected this type of problems. You see, I have given here a assignment of 30 questions, in which this is the first one, and the second one is this. Just you have to here you have to write cos square x is what 1 minus sin square x, and apply sin 1 a minus theta formula, you will get the answer. Here you have to go for sin x. Sin x is what t you take down and differentiate, you will get the answer. You write the expansion, okay, and this is what based on expansion I've given, and this is application of here sin x you replace by x, you will get x square, and apply L'Hospital rule, you will get, and already I discussed this one, we got the answer also -1. It is also what 1 to the power of infinity related problem it is. Here you have to multiply and divide with 1 minus x, and keep on simplifying, you'll get it here. This can be written as 2 into 2 factorial can be written as 3 factorial minus 2 factorial. Like that, 3 into 3 factorial can be written as 4 factorial minus 3 factorial. It will be like this. Cyclic, simplify, we'll get the answer. Here you have to multiply with this sine x by 2 to the power of n. You have to multiply and divide with sine this. And simplify, you will get the answer sin x by x. I'll turn the page. See here, next one. Here, right. Here also what? Write the nth term. See, second term means 1 plus 2x. Nth term means 1 minus n minus 1 into 1 x divided by 1 minus. Here x is there, na? There. 1 minus. Nth term na? Nx. The next one is 1 more than that. N plus 1 into x. And simplify. Right. You will get the result. Here if you apply sigma, you will get the answer here. Okay. This is also one of the easiest one. You just take LCM, right? Because the result is 0. So highest coefficient should be what? X square coefficient should be 0. And there should not be any x square. So there you will get the result AB. Here you take x square common and x cube common here. Here x to the power of 4 common. Here x to the power of 5 common. Then whatever is left over, you apply the rule, you'll get it. Straight away you differentiate here, you'll get the answer for this 14th one. Here you can take the factors, cos 2x as common, write express as the factors here. Then afterwards, using this formula, cos n ax divided by x square, limit x tends to 0, you'll get what? N a square by 2 formula, you get it. And this is also one of the beautiful question, right? After molding, you'll get it here. And sine to the power of nx is there here. Here, Nana, you are supposed to eliminate 3 to the power of n from the denominator and numerator. And then afterwards, you start comparing here. You'll get the answer as what this, right? 3 to the power of n, you have to take common and cut it. Okay, simplify, you'll get it here. N into 3 to the power of n, it's better, I think, if you take. And you know very well here, sin x is less than x, less than tan x, you use and simplify, you'll get the answer here. And here it is series, Nana. You know very well the series, how to write, okay. So 1 by 2 to the power 2 k square can be written as something you multiply divide with 2 like this, huh? Tan inverse something 2 divided by 4k square. Later onwards add and subtract 1 and try to express in the form of what? Tan inverse of x minus y by 1 plus xy. Simplify, you'll get it. Here, r cube plus 1 by r minus 1. R cube plus r plus 1. r cube minus 1 by r minus 1. You write in this way and expand, you'll get it here. And here is one of the easiest one. Why? Because A2 if you take, LHL you take down is 1, you'll get. RHL you take down, you'll get what? Minus 1. So does not exist, you'll get it here. Right. And in this case, limit n tends to infinity f of n plus 1 is same as limit n tends to infinity f of n. So a quadratic equation, while solving, you will get the answer here. And this is also what series, you know very well. R square minus R plus 1, R square plus R plus 1, two factors will get. Just you multiply, divide with 2 and express as a cyclic form, cut this, and finally you will get the answer. Here you are supposed to rationalize. If you rationalize, you will get this banana. Okay. And the next one, here what you are supposed to do is, this is one of the great question, guys. While doing this, you please take care of yourself. You have to write f of x first, then afterwards g of x you'll get here. I think converting into what? Sandwich rule. Yes, by using the sandwich rule, we'll get this one. And this is rationalization. Okay. And come to this one is, what exactly you have to do is, okay, you use this one and get the value of f of 2, okay, f of 3, f of 4. You can understood. You will get here something f of x is equal to x will get. By substituting 2, 3, 4, etc. X is equal to, okay, f of 2, f of 3, f of 4 values. If you try, finally you will get what? Identity function. If you got like this, immediately you can go for this. This is nothing but f of tan x means only tan x. F of sin x means only sin x. Here, x square sin x. I hope that you will get in this form, I think. 2 to the power of tan x minus 2 to the power of sin x divided by x square sin x. Of course, limit x tends to 0 is there. There afterwards, use the formula. Use this formula. A to the power of x minus 1 by x is equal to log a formula. And you will get the result here. This is wonderful one. And the next one, sir, this is little bit difficult one. Please express this all things. Take this as y, this part. Okay, this part you take as y and apply logarithm. So try to simplify, then afterwards use that. It take time. Applying logarithm is one of the idea. Straight away you differentiate here. While differentiating x to the power of x whole dash formula, x to the power of x 1 plus log x formula you have to use here. X is variable, y is constant, please remember that. Okay, and it is just LHL and RHL. You will get the answer here 8 by 3, whereas here it is minus 3 you are getting. And this, mod x by x form is there. So I think probably you are going to get 3 values here, 3 roots values you are getting. Hope so that you people can follow this all. And afterwards, guys, it is very clear. I want to tell you clearly that this is assignment, one example paper, some 15 question from PVA, PYQs, and 10 question from good questions. Overall 25 question paper, one we have to discuss in this one. In every topic, if you do like this, one assignment after knowing all the types, an assignment, one question paper, I think your preparation is okay. Right? You will get the best. You can do best in the exam. Okay, guys? Right. Thank you, guys. All the best. In the next class, if possible, I would like to give the question paper and afterwards the explanation. The solutions of this one is also I'll upload. Right? Bye. Have a nice day.